Hello, and welcome to our discussion on anti-Markovnikov addition of HBr to alkenes. This is another video in our radicals reaction series. There's a couple of these already. So now we're going to add one more really cool reaction to our synthetic toolbox. All right, so as we said, this is part of our radical reaction series. So the first video was about just radical reactions in general. So it talked about the mechanisms and how they're different, how the arrows are different, things like that. And then we talked about alkane halogenation. That was the first reaction, which we have an alkane and add a halogen with an initiator of light to make a radical. And then it's going to add to the most substituted carbon spot. The key part of that reaction is making the most stable radical. That's why the bromine adds to the most substituted carbon in this scenario. So the radical would look like this, so it's tertiary, and then it removes the hydrogen to make that radical. So that's how that one is formed. Comparing reaction 1 to reaction 2, we can see there's quite a few differences. So for this one, we're going to add to a double bond, so we're sort of switching up what we're starting with, but it's still going to go by a radical mechanism, and that's why it's going to be relevant to this section. So that's going to be reaction 2, as we've shown here. All right, so let's get into those details. So as we said, this is a reaction with an alkene. It's an addition reaction. That means we're going to add something to the double bond and we're not taking anything away. So this is similar to a reaction that you've probably already learned, which is Markovnikov addition of HBr. So if you look at example A, that's probably the reaction you've seen before. And so as you can see, it's very similar to reaction the example B, but we just have the peroxide and the heat. So for the first one, it's a regio-specific reaction where the bromine goes in the middle. That's called Markovnikov. It's where it goes on one of the carbons of the double bond and it goes on the more substituted carbon or the one that makes the best intermediate. So remember, the reason for that is because it's going to make a carbocation. So the very first step is it's going to add a hydrogen and then it's going to make this carbocation. Because if it adds to the side, that's going to make us have a secondary carbocation. That's better than adding the hydrogen to the middle, which would leave the positive on the right side, which would give us a primary carbocation, which is less stable. So that's why we form the intermediate that we do. All right, so hopefully that looks familiar. Now, we notice with slightly different reagents, we're getting a different regiochemistry, right? We're still adding hydrogen and bromine in example B, but instead we're getting it on the side carbon instead of in the middle. All right, it's still going to add to where the double bond is, though, so it's not going to do any rearrangement or anything crazy. So obviously that's a signal to chemists that there's a different mechanism going on. If it gives you a different product, regiochemistry-wise, then that means it must be doing something different, all right? From this reaction, I can tell that it's going to be a radical mechanism. What is the thing that shows me this is probably going to have a radical? Right, remember it says it has an initiator. So the initiator would be this roar, that's the peroxide. Peroxide in heat, we said, is an initiator for radicals. So that's how we'd remember that that's what that is if we didn't know that already, okay? So the key thing we're going to notice about these two that makes it different is what you're adding first. So if you look at the top one, the first thing we were adding was the hydrogen, right? And so we got a carbocation that was secondary. That's what we got first. What we're going to see for example B is that we're actually going to make this key radical here. So it looks like that. And we've added the bromine first. So it's still making something that's secondary. So that's going to be something stable, but it's going to add the bromine first, and that's why we get a different product. So let's dive a little bit further into this mechanism so we can understand where that key intermediate comes from and how we get to the final product. All right, so I've redone the reaction up at the top, so we have plenty of space to do the mechanism now. So remember we said our key intermediate for this one is going to be the radical where the bromine added first. I'm going to put that up as reference so we can figure out how are we going to get this key intermediate and then how are we going to get from the intermediate to the product. All right, so the very first thing we have to do is remember, because it's a radical mechanism, we have to do some sort of initiation. Now before, we were able to get the bromine radical itself from more bromine, right? But in this case, that's not going to work. So if you maybe recall, a double bond being mixed with bromine, the reagent, is going to make a different product where two bromines are going to add to the double bond. So we can't throw a whole bunch of bromine in there, Br2, because that's going to make a different product. So we got to use something else. So in this case, we're going to make the Br radical again. We are going to make that, but we're going to have to use a different initiator first. So what's our initiator for this reaction? right? We said it was the peroxide and the heat. But you notice there's no peroxide in the product, so it's just going to get used and make a byproduct. So we'll see what that looks like. So to do an initiation step, we need to draw out the peroxide, and we know that the OO bond is going to be the weak bond, so I'm going to draw that out so it'll look like this. And then we're going to do initiation. So how many arrows do we need for initiation? Do you remember from our first video, our introduction? Yeah, it's going to be 2 arrows, right? So we go from no radicals to having radicals by using 2 curved arrows, and they're going to be fish hook arrows. So make sure you draw only one side on the little triangle part, okay? So it's going to look like this, and then the product of that is going to be the RO dot. That's going to be the radical that we make. We technically make 2 of those, but you don't have to show both of them because they don't both do something. Now, the RO dot is not in our product, so if we see that, that's not going to add directly to the double bond, that's not going to help us. We need to make BR dot. That's the radical that we're going to use. That's going to be the key. So where could we get some BR for this reaction? Right, we're going to use the HBr because that's the only source we have. So to get that, it's pretty easy. We're just going to take off the hydrogen. It's called a hydrogen abstraction. It's not an acid base because it's not an H+, but that's how it works. So this kind of step is going to be which kind? Is it going to be initiation, propagation, or termination? Right, it should be propagation, right? All the ones after the initiator should be propagation steps. So in this case, we're going to have how many arrows? Right, 3. So we're going to have 3 arrows. So we're going to have the RO dot is going to, we'll just draw an arrow going sort of to space. And then what's going to connect with that is going to be the hydrogen. So we're going to go from the bond, because that's where the electron is, with a one-sided arrow to meet that so that they can bond together. And then the other one to finish breaking the HBr bond is going to go from the bond to the Br. Okay? So then the product of that is going to be Br dot. And we also get a byproduct, and that byproduct is going to be RO with the H attached. That's just an alcohol. So whatever the R was, if it was like, say, a tert-butyl, that's a common one, then it would make tert-butanol. That's what it would make. So we'll draw that over here if you really want to know, but you don't have to draw that. Okay, so it does exist. It's not doing anything. We'll just draw it off to the side. Okay, so the main thing we wanted to make was the Br dot. So I'm going to put it right here so we can use it for the next step. So hopefully everything's okay so far. All right, so then once we have the Br dot, that's where we're going to do our addition part. So it's actually going to add to the double bond so we can make our key intermediate. So if you look at the Br dot, we're going to have that make a bond. So we need to have it draw the arrow from the radical just sort of out into space. And then it's going to bond to the carbons of the alkene. So it's going to add to the alkene. So we need to draw an arrow from the double bond to meet up with this bromine dot. Okay, so that's making the bond to add the bromine. Then we're going to break the double bond the rest of the way, so we have all single bonds, by adding an arrow that goes to the middle carbon, right? Because that's where the radical is going to go. So then that's how we draw that. So again, 3 steps. That means what kind of reaction? Propagation, right? It's a propagation step. So then we've made our key intermediate. So we're almost done. It's very exciting. Okay, so why did it add to this side and not to the other side? So what kind of radical do we have? That's the key, right? So is this primary, secondary, tertiary? Right, so this should be secondary. So the other option, if we'd added it to the other part of the double bond, would have been a primary. So if you look at it, it would be this. So we're saying not this, so we're not going to make this. So it looks like this primary dot, right? That's not what we want. So that's just less stable. Okay, so that's not what we're going to make. So let's focus back on the one we're starting with. So the last thing we need to do is add one more thing to get the product. What are we missing in the product? Right, it's a hydrogen. So we have to get the hydrogen. Where can we get a hydrogen from? Couple of options, right? We could get it from the byproduct that we made, this alcohol, right? But we don't have a lot of that, especially in the beginning of the reaction because it's a byproduct. And as we said, for initiation, we're not going to actually have to use a whole bunch of the initiator, so we will usually have less of that in the reagents as well. So where's the other place we can get a hydrogen? From the HBr, right? This is going to be the thing that's going to sort of close our loop so we don't have to keep using the initiator again. And what type of step should we have for the last part of this mechanism? There's only one more step. Initiation, propagation, termination. Right, we're going to use propagation. We said for organic reactions, we usually want to show propagation and not show any termination things. In this one, it's easy. You're not going to be tempted because there's really no H dot you could have combined it with, so it's less tempting to even try termination. But don't do that because we're not doing that anyway, which we talked about in the first video. All right, so what we're going to do is we're going to make a bond with the hydrogen of the HBr. So we need to draw the HBr with a line, and then we will have the radical from the carbon go sort of out into space. And then from the bond to the space is how we're going to connect that hydrogen to the middle carbon. All right, and then we need one more arrow. What's our last Fishhook arrow? Right, we got to break the bond. So we got to have the go from the bond to the bromine, and that's going to make more Br dot, our key radical that we're going to use. So that radical is going to go back and then start the reaction part right before the initiator part. All right, so that's it. That's the whole mechanism. If you notice, this one's a little bit longer than the previous alkane halogenation mechanism. That's partially because it has more things you have to do to sort of get the reaction going to get to that Br dot part. So maybe we'll just say like what we're doing in each step just to make sure we're keeping it straight. All right, so the first thing that happens, that's the initiation. So we'll go ahead and label those steps. So initiation, and then the next step is a propagation, right? So then what's the next step where we have the Br dot attack the double bond? Right, that's another propagation. And then how about the last step? Also propagation, right? And then now let's go ahead and put this into words. I like to put the mechanisms into words, as you've probably seen, just because it helps you keep track. It's a little bit easier to remember the words than sometimes the pictures. So the first thing that's going to happen is you're going to do the initiation. So you're always going to break a weak bond. That's what initiation is. So that's the first thing we're going to do. All right, and then we get the RO dot, right? We said that. So then the next thing we need to do is we need to make the BR dot. That's our goal. So to do that, that's why we did this step. Okay, then the next thing we did up here at the top was we added the BR dot to the double bond. So we'll write that down. Again, we're going to do it so it's going to make the best radical. So that's how we're going to know which direction that the breaking bond one goes. Okay, and then we've got our key intermediate, that radical with the Br on there. And then the last thing we're going to do is we're going to get the hydrogen. So I just put the carbon radical gets the hydrogen. That's the easiest way for me to remember it. You could call it something else if you want to. Okay, great. So hopefully that helps like maybe make it a little bit easier to remember, but obviously you want to practice this one a few times because it is a little bit more steps going on. All right, great. Okay, so let's move on. So as not to get so distracted by the mechanism that we forget how practical this reaction is, let's talk about what the product is. Let's make sure we can predict it. So remember we said we're going to add a bromine and it's going to be anti-Markovnikov. So that's the cool thing about this reaction is we had one way to do it Markovnikov, now we have another option. So synthetic chemists love this reaction. All right, so we know we're going to have to draw the product. We first want to draw the product that is the same carbons, right? So none of the carbons are going to change. So we'll draw that first. Okay, and then which carbon are we going to add the bromine on? So if I number them over here, 1, 2, 3, 4, 5, then where is it going to add on this structure on the right? It's going to add in carbon number 4. Right? We know it has to be either 3 or 4 because it has to be where the double bond is and we don't really see a rearrangement for this particular reaction. So in this case, it's going to be either 3 or 4. We want to have the intermediate would have been the radical would be on 3. So that means that the Br would have to be on 4. Right? So then the final product, you don't have to show the hydrogen because it's line bond form. So then that would be the product. Great. All right, so hopefully that makes sense. But again, always let me know if it doesn't. And we're done with this reaction. And with that, we're also done with this video and radicals for this section of material. So make sure you check and see if there's any activities or if you're doing it for another class. Obviously, you'll see what your professor does. But thanks so much for sharing this time with us and learning more about radicals. Thanks. Bye.